Okay, we will start with where we left yesterday. We were using the layered architecture of the system. For the layered architecture, we have taken a specified task where we have one sender who wants to write the letter. The sender is writing the letter. Okay. The sender is, we have a sender and a receiver. And at the sender's layer, we are actually defining the tasks that are performed at the sender's end in three different layers. The three different layers are higher layers, middle layers, and lower layers. The layers that are defining each layer is performing an independent task. At the same time, each layer is actually helping the other layer for the next task. At the sender's end, we have a higher layer. The sender writes the letter, inserts the letter in an envelope, writes the sender's and receiver's address on the envelope, and drops that letter into a letter box. These are the tasks that are performed at the highest layer or higher layer, where sender actually performs all these tasks. Then at the middle layer, the letter is carried from the letter is picked up by the letter carrier and delivered to the post office. Some person is assigned who will pick up the letters from the post box and will take all those letters from the mailbox to the post office. These are the tasks that are performed by middle layer. See, all these tasks are independent tasks. At the higher layer, sender is writing. This particular task is not at all related to the letter being carried from mailbox to the post office. That's why we can say that at every layer, we have some independent task that is being performed. At the lowest layer, the letter is sorted at the post office and the carrier transports the letter. The parcel is carried from the source towards the destination, whatever may be the mode. That particular mode, if a courier person is taking, courier person have their own medium for transporting the letters. If post office is delivering the letters, then there are standard operating procedures associated with the post offices. So the post offices, based on the distance, based on the postages, based on the stamp that is put on the envelope, that decides auditing facility associated at the sender's end. Depending on that, the letters is dispatched at the destination end. So at the receiver end, see, at the sender's end, the tasks are performed by higher layer to the lower layer. But at the receiving end, the processing starts at the lower layer. The carrier transports the letter from the post office, or the initially from the communication media to the post office, then our destination post office, then that letter is sorted and carried from the post office to the mailbox of a specified person or mailbox of a receiver. So that is the middle layer. The letter is sorted and delivered to the recipient's mailbox. Then at the higher layer, the receiver at the destination picks up the letter, opens the envelope, and reads it. These are the tasks, these are the functions that are performed. At the sender's end, the tasks that are performed, the letter is written. At the receiving end, the letter is read. At the sender's end, the letter is put in an envelope. At the receiving end, the letter is drawn from the envelope. At the sender's end, the after sealing the envelope and writing the addresses, the letter is put in the mailbox. At the receiving end, the letter is picked up from the mailbox. These are the tasks, these are the primitives, these are the facilities that are performed at every layer. And that's why this particular type of architecture of delivering a postal letter was utilized in developing various layered architecture for computer network. The hierarchy typically that is being maintained at every activity. At every activity, the letter must be returned, the letter must be dropped in the mailbox before being picked up by the letter carrier. Or at the receiving side, the letter must be dropped at the recipient mailbox before being picked up and read by the recipients. This is having a specific hierarchical functioning at the sender's end from higher layer to the lower layer, and at the receiving ends from the lower layers to the higher layers. And each layer is providing the service to the lower layer and the adjacent layer. That is, the higher layer is providing the services at the center end to the middle layer. Middle layer is providing services to the lower layer. Again, I am telling you that all the tasks that are performed by the layered architecture at various layers is the independent task. But still, there is some correlation in providing some specified formatting or specifying the services to the adjacent layer. If it's the middle layer, it's actually providing the services to the upper layer, as well as it's also providing the services to the lower layer. The services to the upper layer, that means the higher layer, once the letter is written, that particular letter is posted in an envelope, is put in an envelope is put in the mailbox. That specific service sequence is always maintained. The middle layer uses the services of the lower layer. The lower layer uses the services of the carrier. The carrier, whenever we are talking about the carrier, this carrier, the lower layer utilizes the services of this carrier, both the lower layers. Here, the letter is being carried from source to destination end. This is source and this is destination. And this typical configuration associated with the networking architecture, helps us in defining proper hierarchical layered architecture for the data networks. And that gave rise to the development of a standardized model. The initial functioning associated with the programs were started way back in 1973. In 1973, in 1970s, basically ARPANET, Advanced Research Project Agency in US, first of all, utilized the networked data terminals for sending the information of the defense terminal from one end to another end in order to carry the specified task, in order to carry the information from one end to another end. Initially, the configurations were supported these configurations that were supported by the research project agency. The various layered architecture for the network layer were suggested, supported, and various groups were simultaneously working on the standard operating procedures for carrying the information from one end to another end. And that gave rise to some sort of standardization. Why standardization is required? The standardization is required so that this particular open system need not provide, or the open system need not provide the services. Just a minute, I will come back to you again. Okay, the layered architecture for the network model processes the various tasks into smaller tasks. A big task is divided into a smaller task. Each small task is then allocated to a layer, a particular layer, which works dedicatedly to process the task. Every layer processes or provides or performs only a specific work. Just now I have told you the each layer performs its tasks independently. All the tasks are independent tasks that are performed at the layer. Still, there is an interconnectivity in the layers so that a proper flow of information needs to be there. And that gave rise to the layered architecture defined in the early 1970s. In the early 1970s, the open system interconnection model, research on that model was started. It was defined initially as a conceptual model. This conceptual model that characterizes and standardizes the communication functions. Characterizes and standardizes. Open system interconnection, the standards never tells you what type of equipments are to be utilized at various layers. In case of sending of that letter, we can see that if the letter is given to a courier person does not provide any type of stamping associated with the envelope apart from the procedures that are adopted at postal office specified auditing information or financial transactions associated with transmission of the information is done at the post office. That is, post office takes some cost for delivering that letter from one end to another end. The processes and the interfaces may be different whenever the communication media changes. And that's why there was a need to standardize each and every process at every layer whenever the data information needs to be exchanged. International Standard Organization, though it was started in early 1947, the actual work for the standards associated with the data network was initiated by the various programs that were first of all or initially worked on by the various government agencies. In 1971-72, actually the processes were suggested by the ARPANET in US and NPL network in UK. They were the first players in mid 70s. They first of all tried and achieved also some sort of data networking. Similarly, in the US, along with the government agencies, IBM was also instrumental in developing their own layered architecture. IBM still follows their own layered architecture. It's typically known as a SNA type of architecture. SNA, Simple Network Architecture. This IBM's SNA is a proprietary type of architecture. They are not at all utilizing, or though it's based on the open system interconnection model suggested by the ISO, but still IBM The work for IBM model was started way before the OSI ISO model was suggested, and that's why IBM kept their own proprietary SNA architecture. But again, in 1973, it was the need by all the countries to provide the common networking equipments. Even if the topology is being different, the common networking equipments were the need of the time, for which some standardization associated with the processes. Everyone was agreeing that we will be utilizing the packet switching. The data may be divided into number of packets, and those packets will be then properly communicated towards the destination through any available path. So initial standardizations that were suggested were based on the specified standard known as X.200. X.200 was the series of recommendations which were utilized by International Telecommunication Unit and defined the first documents required for the OSI standard. So some of the protocol specifications were also provided to another ITUT X series standards. But again, there was industry effort to standardize some sort of equipments as well as some sort of hardware as well as some sort of functions at various layers, and that gave rise to the development of ISO OSI model, open system interconnection. It was initially introduced in 1970s, but it was effective after 1980. After 1980, it was effective, and in 1991, the OSI model, ISO model was translated to provide the services specifically to the network of network, that is internetwork. So it was the start of the internet in 1991. Still, we can say that it's a recent development associated with the data communication, but that has changed the entire face of the world. And various vendors, various developers, various original equipment manufacturers, OEMs, were the boost to the economics of the various countries, which utilizes the computer communication system. And this computer communication system gave rise to our OSI model, where the OSI model suggested by the ISO International Standard Organization and open system interconnection is the model. The model provides us seven different layers. Seven different layers. The model is divided into seven different configuration, which provides the interconnectivity of the sender and the receiver through these seven layers of OSI model. The topmost layer in this particular OSI model is the application layer. The sixth layer is the presentation layer. We will be seeing the functioning of all these layers in all our coming lectures, because all our units are based on either the facilities, functions, protocols, procedures that are designed based on the specific layer of the OSI model. Though at present we can say that OSI model was initially a standardized model, but nowadays, and it was supposed that this OSI model will be utilized by everyone. But again, it was not at all the case, and that's why another model, TCP/IP model, which was utilizing some facilities based on the OSI model, but the number of layers associated with that TCP/IP model were less, and that TCP/IP model was again a standardized model, and still it's a de facto standard that is being utilized by the internet or network of network. But we can say that OSI was the first attempt to standardize the equipments, to standardize the devices, to standardize the common communication equipments that are utilized as the interfaces to the communication medium. OSI ISO model never tells you what sort of hardware is to be utilized at which layer. It's a standard. It does not tell you, but it only suggests that the functioning of the developed equipment should be based on the functioning suggested at every layer of a OSI model. Get it very, very clear. OSI is a standard. It does not tells you what type of equipments are required at what layer. The basic model, the communication protocols in a layered architecture initially suggested that this particular configuration of a OSI is to be utilized for the data networks. For the data networks, that means whenever the data processing is to be a typical, or a data translation is the typical process in the two entities to communicating OSI compatible devices. It was the initial word that was utilized for the data network, but at present we can say that any data terminal with networking capabilities and with the processing capability for the incoming data at both the station and sending the data from that station can be a data workstation, which is one of the data terminal in the computer communication system. Whenever the data is to be transmitted, the data is typically composed at the highest layer or the topmost layer of the transmitting device. And say for this particular OSI model, the topmost layer is the application layer. So whatever data that is to be transmitted from the sender's end to the receiver's end, the data is composed at the application layer. Then the data is translated to the lower layer, so that that particular data that is being composed at the application layer, a specific header to that data is added, that is known as an application header data unit. That application header data unit is translated to the next layer, presentation layer. Then presentation layer processes, performs the services on that data. So all these in between layers are also known as service layers. These service layers adds their own data unit. So whenever or it adds their own header, adds their own header. So right from the hierarchical way, from the seventh layer to the lowest layer. Typically the seven layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, out of which the configuration is divided into top four and lower three, so that the intercommunication in the two terminals is basically at the lower three layers, and whenever actually data is to be exchanged, all the in between layers will communicate for these lower three layers, and whenever data is to be retrieved, all seven layers will be utilized at the receiving end. We will see what is the actual meaning associated with it. Whenever the topmost layer is suppose n, the services are provided by n minus 1. It adds its own header. The service, then the data is provided to the session layer. It adds the session layer, add its own protocol unit, process or protocol data unit. It typically the header that is being added. In such a way, all the headers of the services that are provided by the various layers are added to the data. At the physical layer, the physical layer will carry this physical layer will carry the data towards the destination end, where also that device will be a OSI compatible device, which will retrieve the data in a same hierarchical way, in the same hierarchical way by stripping off the header that is being added at every layer. What is this actually? The process continues from the top layer to the lowest layer. The receiving data is passed from the lowest layer to the highest layer as the series of service data units while being successively stripped from the headers that are being added, the headers that are being added from the topmost layer. It's, I'm just for simplicity providing you that headers are added, but in practice we are adding the headers as well as the footers for the actual data, which provides the information of what procedure is utilized. What procedure, that means what type of protocol is utilized at every layer. And that gave rise to the development of various protocols based on the ISO OSI model. ISO OSI model, this ISO OSI model, just now I have told you. Here now actually we are considering the translation of the data from device A. The device A and device B wants to exchange some information. And in between device A and device B, there are some intermediate nodes. These intermediate nodes, this particular symbol is a specific symbol of a router. The data packets from device A are routed by the intermediate nodes towards the destination. There may be n number of intermediate nodes in between A and B, but A is sending the data over the common communication media, which consists of the various intermediate nodes. So the data packets will hop from device A to first intermediate node, then the data will hop from intermediate node to the second intermediate node, and to the n intermediate nodes that are in between device A and B, and then finally the hop will be from the last intermediate node to the device B. Virtually, the peer-to-peer protocol at the every layer will function its own, but the hierarchy that will be followed will be from application layer to the physical layer at the sender end, and from physical layer to the application layer at the receiving end. And for all the intermediate nodes, we are utilizing only three different layers, which will help in sending the data, reformatting the data at the specified network layer, and sending that particular data again to the nearby intermediate node, and then finally translating that data to the destination end. Here the terminal source end will be device A, device B will be destination. Whatever information the source A want to send, that information needs to follow the services that are to be provided from the application layer to the physical layer. And at the physical communication, this particular physical communication is nothing but the communication media in between the networking devices and networking terminals, and the data is actually propagated through this particular physical communication media. The physical communication media actually provides us the utility associated with the various types of communication medias to be utilized for the data communication. I think at this particular point I will take a break, I will take questions, and again we will continue for the next. So you can unmute yourself and ask the question. So unless and until you understand this particular concept, it will be very difficult. If you don't understand the concepts of the layered architecture, this OSI model is utilized as a base model in developing the various types of protocol. Though we are not at all utilizing this OSI model as a de facto standard, we are utilizing TCP/IP as a de facto standard, but still for all the protocols, this particular OSI model is supposed to be a base model. And again, it's said that for the cloud computing or the cloud architecture, again, we are utilizing the facilities that are supported in all the 7 layers that are suggested in OSI model. At present, we are utilizing TCP/IP model. TCP/IP model, which was initially developed for the Unix operating system. The Unix operating system, first of all, configured the devices, and the devices to devices delivery was confirmed with the utility of the transmission control protocol for the specified addresses. What is there inside the TCP/IP model? We are actually uh, we will see the in the coming lectures. We'll compare the OSI model as well as the TCP/IP model. But just remember that though it's a de facto standard model, it is not at all used nowadays. But it's the base for all the protocols that are being developed for the data communication. The de facto standard that we are utilizing due to some of the simplicities for that model. It's also known as Department of Defense model, DoD model. The TCP/IP model was initially developed specifically for the defense tasks, but then it was due to the simplicity suggested in the TCP/IP model, it was de facto standard in the US telephone departments, where the protocols that were developed were entirely based on the telephone protocols or post and telephone protocols. And that's why the protocols suggested in the OSI model as well as the TCP/IP model are also known as post and telegraph protocols, P&T protocols. But that was the initial names that were suggested for the specified model. At present, we have two models. The first model is a standard model, OSI model, which is not at all a de facto standard. The de facto standard for our internetworking that we are nowadays utilizing is a TCP/IP model, the OSI model and TCP/IP model. So I think questions. Can put your questions in the chat box also. You can also raise your hand if someone wants to ask the question. Again, Rekha Pawar is not attending. Omkar, उत्तरचंही लक्ष नाही आहे. Someone is listening. Very good. Abhishek, Abhishek Gawande. Okay. Hello. So any difficulty, any doubt? Yeah. Divesh Gaikwad. Divesh.
I was having the
Yeah. Okay, just a minute. Huh. Yeah, you can speak now.
sir in that 7, 6, 5th and 4th layers they have peer-to-peer protocol. Okay, and 3, 2 and first layer they are not having that. Means in their in that diagram you were shown last time. Network, data link. So why is that?
Yeah, that PPT, the lowest layer, the lowest 3 layers are not at all providing actually. Peer-to-peer protocol actually provides the virtual services directly to the upper 4 layers. that is the application layer. Application layer, whenever you are creating an application at the sender's end, the similar type of application is needed at the receiver's end. So it's the peer-to-peer service that is being offered to the incoming data. Then and then only the peer-to-peer configuration will helps us intelligently in retrieving the data. Whereas the peer-to-peer services are not at all required at the lower three layers. These are just the repeaters. The lower three layers are the repeaters. Physical layer, data link layer, and network layers are providing us the repeaters and a retransmitter configuration for the intermediate node. And that's why peer to peer is not at all written for the lower three layers. But it's the facilities, the functions, the primitives are required at these upper four layers, and that's why it's written as peer-to-peer protocol for the upper four layers. That is starting from the network layer, transport layer to session layer to presentation layer and application layer. The lower three protocols helps us in hopping the data from one network to the other network. The hopping is the network in between the source and destination end. Is it clear?
Sir. And what is that? Any example for peer to peer?
Say word application. I am creating a doc file with a topmost layer. Topmost layer, that is application layer. I am creating a doc file. The doc file is say in a compressed mode. That's a typical presentation for the doc file. The doc file is translated or is to be opened with a specified session that is being created in between device A and device B. And at the transport layer, the specified application protocol, transport protocol, session protocol, and presentation protocol units need provides the information at the receiving end that at the presentation layer the file needs to be decompressed, and whenever the at the presentation layer the file gets decompressed, it's provided to the application layer, which provides the information that a specific application to read the document file must be available at the application layer. It's not that always Word. The document may be opened in say WordPad or it may be opened in OpenOffice. But that particular information must be always provided as a peer-to-peer service for the four upper layers. Similarly, the typical presentation always I give you the example of a PDF file. The word initially at the source end, a word file is created. Then that word file is converted to a PDF file at the presentation layer. The PDF file will be opened in a specified session which is in synchronization with the device end, both the devices end, that is device A and device B. So at the receiving end, at the presentation layer, it will inform to the receiver that the file, even if that is being created or converted from doc file to the PDF file, a PDF reader application must be present at the application layer. Then only the PDF file will be opened at the device B. Okay, any doubt or is it clear?
Yes, sir. Yes.
The 7 layers are quite important. How to remember these 7 layers? It's not very difficult. The lowermost layer is the physical layer. The connectivity or the communication media is always connected to this particular physical layer. We are going to see the functioning of all the layers, but it's the physical layer. Then it's the data. that is being linked to the communication link. And that's why the name data link. The packets are to be transmitted over the network. That's why the upper layer is the network layer. At the application layer, we are actually providing the application packet data unit, which will be the header, which will provide the information along with the data that this specific application is utilized. Then it's handed over at the source end to the next layer, that is presentation layer. Then from the presentation layer, it's handed over to the session layer. Transport layer actually provides packet to packet delivery from source to destination. And that's why these four upper layers predominantly plays an important role in retrieving the actual data. And lower three layers helps in properly providing the networking configuration, which may be a switching configuration, which may be a virtual path creation, which may be a circuit path creation, which may be a media to media connectivity in source and destination. So the packets which hops from one network to another network is shown as an intermediate node in source A and destination B, or device A and device B. So we'll come again to the presentation. Any more doubt? You can raise your hand. I can see who has raised the hand. Anurag Chaudhary, any?
No doubt, sir.
No doubt. Swati Chavan. Yes, Swati. We will continue with our presentation again. Now see the seven layers. The lowest layer or the first layer in the OSI model is typically known as a physical layer. What are the functions at this particular physical layer? The physical layer is responsible for the transmission and reception of unstructured raw data between a device and a physical communication medium or physical transmission medium. It's responsible for transmission and reception of unstructured raw data. That is the information in the form of digital data, zeros and ones. How these zeros and ones are dumped into the transmission medium. That is the function, that is the important function associated with the physical layer. The physical layer actually converts the digital bits into the electrical signal or the optical signal or the radio signal. The layer specifications at the physical layer defines characteristics such as the voltage levels, the information that is to be carried whenever in the form of electrical topology, then the signal is sent as the difference in the voltage level, the timing of the voltage change. This actually defines the physical data rate, maximum transmission distance, modulation scheme. Just remember all these channel access method and the type of physical vectors that are used. It actually provides us the media connectivity, the physical connectors that are required for the media. Say if your communication media is optical fiber, then the information at the physical layer that is obtained from the device A is in the form of digital data. This particular digital data is to be communicated as an electrical signal converted as the voltage difference. So if we are utilizing a differential voltage strategy, then 0 will be transmitted as say minus 5 volt and 1 will be transmitted as plus 5 volt if we are utilizing the positive logic for the communication of the digital data. But this particular decision of converting this electrical signal to again the optical signal, if optical fiber is utilized as a communication media, is performed by the physical layer. The wired connectivity or the wireless connectivity, the frequencies that are defined, are all the tasks that are performed at the physical layer. The connectivity at the physical layer actually defines the network topology that we have seen, this, whether the topology is a star topology, whether this particular configuration, the typical configuration utilized at the two layers, at the lower layer, say the three layers, which actually defines the interconnectivity in the in between device. Suppose the first network up to this, suppose we are utilizing for all the devices, say device A and first intermediate node, they are actually connected in the star type of topology. And if the second part, second intermediate node and device B is utilizing a bus type of topology, then star to bus type of topology interconnectivity needs to be provided at the physical layer in between the two intermediate nodes. And that is the functioning that is being associated with the physical layer. The components of a physical layer can be described in terms of network topology. Again, I am telling you, it's a network topology that is defined at the physical layer. The physical layer specifications are the specifications for the Bluetooth, the specification for the wired, specification for the wireless, specification for USB to USB connectivity between the two devices, specification for all types of media interfaces. This particular physical layer, whenever we are utilizing in the industrial connectivity, the CAN type of standards, the various types of industrial protocols also follows the suggestions that are defined at the physical layer of an OSI model. So once again, the physical layer defines the unstructured raw data transmission. It defines physical medium. It defines voltage levels. It defines timing of the voltage levels or voltage changes. It defines physical data rates. It defines maximum transmission distances. Maximum transmission distances that actually defines the topology. Whenever we are considering the devices to be connected less than 100 meters, then we are utilizing the category 6 type of UTP cable. But if the distance is large between the intermediate nodes, the connectivity may be by the optical fiber as the communication media. So the component at physical layer will change at the intermediate node connectivity, not necessarily at the device A itself. Device A and first intermediate node may follow one particular topology, may follow one particular communication media. The devices and the communication media that is utilized for another intermediate node and device B may follow different type of communication media, but there must be a proper translation from the electrical to the optical and from optical to the electrical if it's a duplex type of communication. Everything that is defined by the well defined suggestions at physical layer. That's a very, very, very important layer that's defined. But still, I'm not at all saying that what type of devices are to be utilized at the physical layer. That is never suggested in the standard, or that is never suggested in OSI model. What type of standard is to be utilized? It's never, never, never mentioned. What type of additional hardware devices or the software strategies are to be utilized at different levels is never, never suggested. You can utilize Ethernet card, you can utilize optical fiber link, you can utilize concentrators, you can utilize various types of hub, switches for providing the physical topological connectivity. And that's true. Whenever we are defining an open standard, open system interconnection, it should include all the devices. It should include all the devices. The devices, the operating systems for the data terminals may be different. At present, we are utilizing RTOS, real-time operating system, for some of the embedded system which are capable of network connectivity, which we call it as IoT, Internet of Things, where the type of operating system for the equipments in the data network may be entirely different. The operating system may be entirely different. Here also device A will have a Microsoft operating system platform. Device B may have a Linux type of platform, but it's the functions at various layers that is actually providing us the translation of the usable information, that we call it as the required data to be translated from device A to device B. Then the second layer, data link layer. The data link layer actually provides node to node data transfer, or it's actually a link between two directly connected nodes. It detects and corrects the error that may occur in the physical layer. It defines a protocol to establish and terminate a connection in between the two devices or two physically connected devices. It also defines the protocol for flow control in between them. So it's the error control, flow control that is supported, or the important functions that are suggested at the data link layer. And it's actually the establishment of a link in between the two devices. Error correction, flow correction, establishment of the link. These are the important tasks. In addition to this, we will be considering what the various types of functions that are utilized by the practical devices, which are designed based on the data link layer. Specifically, IEEE 802, 803, I have told you yesterday, specifically for the devices, networking devices. 802 divides the data link layer. IEEE 802 actually defines the data link layer into the two sublayers. The first layer is known as a medium access control, and second layer is known as a logical link control. Medium access control, MAC. It's also known as a MAC layer. And another layer, it's a sublayer of data link layer, logical link control, or it's a LLC. The MAC layer is actually responsible for controlling how the devices network gain the access, or how the devices are actually properly interfaced to the communication medium, and the permission of data through the available communication medium, that is defined at the media access control or MAC layer. The logical link control actually is responsible for identifying and encapsulating the network layer protocol, that are the higher layer protocols, and controls the error that's being available. It may be a forward error correction or a retransmission of the data if the error occurs, or providing a proper synchronization of the frame of data in between the two layers, so that we can say that at physical layer we have a data in the specified or unstructured raw data in the form of 0 and 1, but at the data link layer we are actually forming a frame of the data, and that particular frame of the data actually helps us in proper synchronization in device A and device B. Device A, if sending a data, device B must identify the specified frame which contains the important information. So, framing is performed by the logical link control layer at the data link layer. These two layers have given rise to the various standards, various IEEE standards, IEEE 802.3, a typical Ethernet standard, I080.11. It's specifically the standard that we are utilizing for connecting our Wi-Fi devices. Then specifically, if you go for the industrial protocols, for the data link layer, the typical standard that is being utilized is 802.15.4. 802.15.4. Typically, example, I'm just remembering these three. 802.15.4 is specifically a standard that is being suggested for Zigbee type of devices at the data link layer. All these standards I have told you: 802.3 for Ethernet, 802.11 for Wi-Fi. There are 802.4, 802.5, specifically according to the various types of devices that are utilized. So IEEE standard actually defines for the various types of devices, but OSI model data link layer again never suggests you what type of devices are to be utilized. So the physical layer and the data link layer. See here, for all these, a proper interface is provided in between data link layer and the physical layer at the device A. It's 2:1 interface. That is second layer to first layer interface. Second layer to first layer interface. The application layer adds its own application protocol data unit, and in continuation, in sequence, or in a hierarchical way, every layer is adding its protocol unit at the sender's end. At the receiver's end, we are actually stripping off all these protocol units that are added at various layers. So, in a synchronized way, the various layers are utilized to provide a efficient data or information transmission through commonly available communication media with open source standards. That's how the functioning associated with the physical and data link layer is. I think at present we'll stop here only. Again, I will take the questions for the physical layer and data link layer. You can add your questions. Pooja Norute. Not attending. Prerna Lagat, not attending.
Yes, sir.
Any doubt, any difficulty?
No problem, sir.
No problem. Everything is understood properly.
Yes, sir.
Rutuja Patil just joined. If you have difficulties, you can stop me at any point and we will discuss those problems and we'll continue.
No doubt, sir.
Saurabh Gadge.
No doubt, sir. No doubt, sir.
No doubt. Omkar Paste.
Doubt, sir.
No doubt. बराच वेळेस अटेंटिव्ह नसतोच रे, बाहेर जातो, दुसऱ्या याच्यावर जातो, दुसरं काहीतरी काम करतो, मोबाईलवरनं कनेक्टेड आहे. ओंकार. गेला, लगेच गायबच झाला. Okay, we'll stop. We'll continue the OSI model, which is a very, very important model. Every protocol, even nowadays, we are designing, we are utilizing the functions that are suggested in a standard model, whether that communication is a synchronous communication or asynchronous communication. That's why it's important to study. Though the practical de facto standard is a TCP/IP model, still, for understanding the concepts associated with the data networking, we must study OSI model. So we'll continue our discussion in the next week also. Thank you. I will end the